Assalamualaikum and salam dan selamat datang. We are the Riser Boys from SMK Bako. I'm Aziz as the leader and the programmer. To my right is Farid as the graphic designer, and to my left is Aishi as the prototype assembler. Did you know that mushrooms to play an important role in solving the climate crisis? Okay, so Sustainable Development Goal number 13 emphasizes the need to solve this issue. We were asked by our teachers how could they contribute on monitoring the environment. In response, we created a project called Hiratake. Our project, Hiratake Smart Monitoring System, aims to monitor the growth of the mushrooms. So we were inspired by an aquaponics project where the plants are automatically watered. We use the inventive principles of trees in our project, which is verification, reversal, and feedback. Farid will provide further details on the principles.
Thank you, Aziz. Alright, for the inventive principle of trees, for unification, we'll be using Arduino board and wires in the prototype. Secondly, for the universal, we'll be using a variety of sensors such as moisture sensor, temperature sensor, and ultrasonic sensors. Lastly, for feedback, we'll be getting results from our sensors to our screen. Alright, for our project, we'll be using the anisotropic field in trees. Basically, we know that anisotropic field is one of the strategies to solve the problem. So here, anisotropic field aims to solve the challenges to create an automation, monitoring, and controlling the Hiratake or the oyster mushroom to solve its problem as well. Even though planting the oyster mushroom is much easier, but because of misconception of watering and suitable temperature for the mushroom to grow well, as the mushroom is unable to grow well. If it's grown, it's still easily attacked by fungus. So as stated in the anisotropic field, difficulty in caring for mushroom is the person who is unable to take care of the mushroom due to its perfect volume of water and relevant temperature. Hence, the F2 comes with the HiSP. Next, for the HiSP Smart System Function Model Analysis, we'll be using the Arduino board, moisture sensor, temperature sensor, ultrasonic sensor, and lastly the LEDs, which is red and green LEDs. For the moisture sensor, we'll be using to detect the water level in the Hiratake kit. If the water level is unequivalent, then the moisture sensor will detect it and pump enough amount of water into the Hiratake kit. Next, for the temperature sensor, we detect the suitable and ideal temperature for the mushroom to grow, which is 28 to 30 degrees Celsius. Lastly, for the ultrasonic sensor, will be used to detect the height of growth of the mushroom. If the height of growth is more than 7 centimeters, then we can harvest the mushroom. Now I'll pass my presentation to Aziz. Thank you.
Thank you, Farid. So basically, if the mushrooms grows to a certain point, it will light up the green LED, which means that the mushrooms are ready to be plucked, but it needs to be plucked manually. So now I'll pass my presentation to Aish.
Okay, thanks Aziz. Now I will explain for the prototype model. So basically, we use Hiratake to create the 3D model for the Hiratake project, and for the Arduino wiring, we use a simulation to simulate it. So this is the real prototype that we use for our project. So for the findings, the Hiratake mushroom needs an average temperature of 28 degrees Celsius to 30 degrees Celsius, and for its minimal growth, it will be 0.1 centimeters. Last but not least, for the conclusion, the Hiratake mushroom needs 75% of water to be moist. That's all from us. Thank you.